You know that feeling, right? You're looking at some new tech, maybe a platform like Databricks, and there's just this flood of information, docs, guides. It's overwhelming. How do you grab what you really need quickly?
Yeah, it's easy to get lost in the weeds. Finding the essential path through it all is tough.
Exactly. And that's what we're going to try and do with you today. We're taking a deep dive into Databricks best practices. We've got this great source document here, lays out setup, operations, practical tips, really solid stuff.
It's a good one, yeah. Very practical.
So our mission really is to unpack this source for you, pull out the key nuggets, the practical steps, those aha moments.
Right, cut through the noise and give you the fast track.
Yeah, basically turn this guide into a clear conversation and make it easier for you to get up to speed and feel confident.
Sounds good. Where should we start?
Okay, let's jump right in. First things first, based on our source, what is Databricks at its heart?
Well, the source defines it pretty clearly.
Yeah.
It's a unified analytics platform built on Apache Spark.
Okay, unified analytics, Spark, and the goal.
The main purpose is really large-scale stuff, data engineering, machine learning, and also, importantly, collaborative analytics, all in one place.
Built for that whole data lifecycle then.
Exactly, end to end.
And why does something like this need, cloud architecture? Why is that baked in?
Because it's designed to use cloud-native services from the get-go. Things like object storage, scalable compute, the security models.
So it plugs right into AWS, Azure, GCP.
Precisely. It leverages their infrastructure. That's how it gets its scale and elasticity, and it helps with cost management, too.
Okay, this is something that often trips people up early on. Where do things like configurations and controls live versus where the actual data sits?
Yeah, that's a super important distinction. So the control plane, think user settings, cluster rules, Unity catalog setup, all that workspace stuff that lives within the Databricks service itself.
Right, access through the UI admin console.
Exactly. But the actual data files, your CSVs, Parquet files, whatever, they stay in your cloud object storage.
So my S3 buckets, or my Azure Data Lake storage, or GCS.
The key thing the source highlights is that Databricks provides the control over that data, especially with Unity Catalog managing access and governance, even though the bytes are in your storage account.
Got it. So Databricks manages the compute, the access, the rules, but the files stay put in my cloud.
That's the core idea.
So if I'm owning or managing this, what are my main responsibilities then? What falls on my plate?
Your job involves key management tasks, assigning roles, permissions to users and groups. That's fundamental.
Right.
Then actively managing Unity Catalog is huge. Making sure data access is secure and governed. Monitoring your jobs is critical, checking for failures, performance issues.
And just general oversight of the governance.
Exactly, keeping the guardrails in place.
This brings us nicely to some of the really key pieces of the platform. Our source highlights a few. Let's talk Unity Catalog first. It calls it the central governance layer. Why is that such a big deal?
It really is central because Unity Catalog gives you one single place to manage all that critical metadata schemas, data lineage, who can access what.
And this works across different workspaces too.
Yeah, potentially even across different workspaces or cloud regions. And that's the fascinating part. The source points out how centralizing this simplifies everything.
Right, instead of managing permissions everywhere.
You manage it once at a higher level. It makes things consistent, much easier to audit. It becomes your single pane of glass for data security and discovery.
Okay, makes sense. And clusters. That's the compute engine, right?
Exactly. That's where the heavy lifting happens. A cluster is basically just a group of VMs set up to run your Spark jobs.
And they're flexible.
Very flexible, according to the source.
Yeah.
They support auto-scaling, so they can grow or shrink with your workload, and they can be ephemeral spin-up for one job, then disappear to save costs, or persistent if you need something always running.
Okay. Now, thinking about organizing the data within this governed setup, catalog, schema, table, how do those fit together?
It's pretty much like a standard database hierarchy, but specifically within that Unity Catalog framework.
Okay.
Catalog is the top level. That's where you usually define your big divisions, maybe by department or major data areas.
Like sales or marketing.
Exactly. Then inside a catalog, you have schemas. Think of those as databases' logical groups of tables.
Got it.
And finally, you have the tables themselves, your structured data. The source mentions they can be managed where Databricks handles the files, or external where you manage the files in your storage, and Databricks just governs the access.
And the source even mentions things like primary keys, foreign keys.
Yeah, it brings up those classic database concepts,
Right.
which means, even in this modern cloud platform, thinking about good data structure and relationships right from the start is still really important.
Good point. Is Databricks locked into one specific programming language? Or is there flexibility?
Oh, definitely flexible. That's a big plus. It supports Python, SQL, Scala, R, even Java.
Wow, okay.
And the really neat thing is you can mix them in one notebook, use a bit of Python in one cell with %Python, then switch to SQL in the next with %EWLO. Super handy.
That is flexible.
Yeah.
Okay, so let's map out the journey. Someone starting a new project. Our source lays out a typical end-to-end workflow. Can you walk us through those main steps?
Sure. The source gives a pretty clear sequence. You'd typically, log in, maybe set up your workspace if it's new. Then, crucially, set up or connect to Unity Catalog. That governance piece is early.
Right.
Then you create or pick a cluster for your compute power. After that, it's creating your notebooks where you'll write your code.
The development part.
Exactly. Then you attach the notebook to the cluster, run your code to get at the data. And here's a key step the source really emphasizes. Validate your data quality early.
Before you get too far down the road.
Definitely. Then you move into the core work, joining data sets, transforming them, maybe optimizing your code so it runs faster. Then you'd export or visualize the results. For automation, you schedule the whole thing using Databricks jobs. And finally, you need to keep an eye on it, monitor the jobs, and maintain the governance.
So why is understanding that flow so important for you listening?
Well, it's more than just a list, right? It's like a mental map. It gives you a predictable path, a blueprint.
Yeah. A blueprint from just getting access to the raw data all the way to having scheduled, monitored insights that are governed properly.
Exactly. It helps you see how all the different pieces connect in the bigger picture.
Yeah. Okay, so we have the core ideas, the workflow. Now let's get into the practical operations, the day-to-day management. What admin tasks does the source call out?
On the admin side, user and group management is obviously basic. You can do it in the admin console directly.
Or automate it.
Right. For bigger places, the source points to using SEM provisioning. Syncing it with something like Azure AD automates adding and removing users.
That sounds efficient. What about costs and rules?
That's where cluster policies come in. You set those up under compute policies. They let you control costs, enforce specific settings like instance types, tags, things like that.
Good for governance and budget and security.
Secrets, non-negotiable. The source strongly recommends using dbutils.secrets.get. You store your credentials securely in Databricks secret scopes.
And for extra security.
It notes that for enterprise setups, you'd often back those scopes with something like Azure Key Vault or AWS Secrets Manager.
Okay. And keeping track of who did what.
Audit logs. You need to enable them, usually from the Metastory settings, but they track key activities, who ran which notebook, access tables, created tokens, etc. Very important for compliance.
And checking on jobs.
There's a dedicated spot, Workflows History. You can see run status, view logs, diagnose failures there.
Moving beyond pure admin. How do we make the notebooks themselves better, more effective, reusable? What tips does the source have?
This is where things get really practical for developers. We mentioned the multi-language thing already.
Right, using %Python, %Queerlo.
Yeah, but structuring code is key. The source suggests calling other notebooks using dbutils.notebook.run.
Like breaking down big tasks.
Exactly. Make it modular. It suggests organizing maybe with April notebooks, utils for common functions. You can also use %mun for including common setup code.
And making them dynamic for jobs.
Parameterization is the way to go there. Using widgets and dbutils.widgets.get, you can pass in dates, file paths, whatever, when the job runs. Super useful.
Version control must be in there too.
Oh yeah, tight integration. Via repos, you connect directly to GitHub, Azure DevOps, Bitbucket, standard Git workflow.
And simple stuff. Documentation, output.
Don't underestimate the simple things. Using %D for markdown cells to document your logic right there in the notebook is crucial. Makes it so much easier to understand later.
For yourself or for colleagues?
Absolutely. And a tiny trick. Adding a semicolon at the end of a code line can suppress noisy output you don't need to see. Cleans things up.
Any other quick operational wins mentioned?
Yeah, a couple of good ones. Definitely use that SEM provisioning if you can. Saves a lot of manual effort with users.
Okay.
Tagging is simple but powerful. Attach tags to your clusters and jobs like environment dev or team finance. Makes cost tracking way easier.
Good for chargeback.
Exactly. And think about setting workspace level quota limits. It can prevent accidental resource abuse or runaway costs.
Smart. And data validation. You mentioned it earlier.
Right. The source really hammers this. Run validations before and after you transform data. And if you find issues, tools like .drop duplicates or .filna are your friends right after you validate.
Makes sense. What about ad hoc checks?
A neat trick is registering a data frame as a temporary SQL view using create or replace temp view. Then you can just run quick SQL queries against it right in your notebook workflow. Very handy for spot checks.
Okay, platform, operations. Now let's get to the core. Working with the data. Exploring, cleaning, joining, making it fast. The source seems to highlight lots of built-in tools just for checking data quality, which is fascinating.
Yeah, building trust in your data is step 0, right? And Databricks gives you a bunch of tools right there in your notebook.
Like what?
Well, you can instantly check the schema with df.printSchema. See the structure. Counting nulls per column is critical. There are easy ways to do that.
Finding duplicates.
Yep. Using patterns like group B combined with a filter for counts greater than 1. Checking data types is easy too, with df.dtypes.
What about outliers or ranges?
The source mentions using a prox quantile for that. And for just basic stats count, mean, min, max, df.describe.show gives you a quick summary.
So these aren't just commands to know, they're like diagnostic tools.
Exactly. The real insight from the source is to use these routinely. Integrate them into your flow, especially before and after transformations, so you know what your data looks like.
Makes sense. Now, joins. Always fundamental. The source lists the usual suspects. Inner, left, right, outer, semi, anti. But let's be honest, picking the right one can still be tricky. What's a common mistake, or maybe a performance pitfall the source hints at with joins?
You're absolutely right. Choosing the correct join type is crucial. Inner, left, right, full outer, left semi, left anti. They all do slightly different things about which rows you keep.
Right.
The source also shows doing multi-column joins, like on EAD source. It means you really have to think, which rows do I need from the left side? From the right, do I need rows that don't match?
So clarity on the logic is key.
Definitely. And a common performance trap is joining huge tables without thinking about the shuffle. Spark has to move a lot of data around.
The dreaded shuffle.
Yeah. Oh, and a simple tip the source gives, use alias on your data frames before joining. It helps avoid confusing column name clashes if columns have the same name in both tables.
Good practical tip. Okay, that leads perfectly into performance optimization. Making things fast, saving money. What are the key techniques the source really pushes?
Performance is huge, right? It hits your costs and how fast your users get answers. The source highlights several levers you can pull.
Like caching.
Caching is a big one. df.cache is great if you're going to reuse a data frame multiple times in your notebook. Just remember, you need to run an action afterwards, like .count, to actually make the caching happen.
Okay, what if memory isn't enough?
Then there's .persist, storage level, .memory and disk. Gives you more options if the data doesn't fit entirely in memory.
What about data distribution, skew?
That's where df.repartition key comes in. It can redistribute data based on a column, which might increase parallelism or fix skew, where one partition has way more data than others.
But there's a catch.
Yeah, be careful. Unnecessary repartitioning forces a full, expensive shuffle of all the data. It can actually slow things down if you don't need it.
Got it. Use with caution. Any join optimizations?
Yes. A big win mentioned is the broadcast join. If you're joining a small table to a very large one, you can tell Spark to broadcast the small table.
How does that help?
It sends the entire small table to every node working on the large table. This completely avoids shuffling the large table, which can be a massive performance boost.
Nice. What about for Delta tables specifically?
For Delta Lake, the source explicitly calls out using the optimize command, often combined with sorter by column.
How does that work?
Optimize compacts small files into larger ones, which is better for reads. Sorter physically rearranges the data within the files based on columns you query frequently, making filters on those columns much faster. Using them together is key for Delta read performance.
And a fundamental thing, reducing data movement.
Absolutely fundamental. Avoid wide shuffles. Select only the columns you actually need as early as possible using df.select :1:2. Less data to shuffle means less memory use, less network traffic, faster jobs. It's simple, but effective.
So with all these techniques, how do you figure out where the bottleneck actually is in your code?
Good question. The source points to understanding the execution plan. In your notebook, you can use .explainTrue on a data frame operation to see the logical and physical steps Spark intends to take.
Okay, that gives you a preview.
Exactly. But for a deep dive, you need the Spark UI. You can usually access it from your cluster's detail page in Databricks.
And what do you look for there?
Check the SQL tab and look at the query plans, especially the physical plan. Look for stages that are taking a long time, spilling data to disk, or shuffling massive amounts of data. That's where your bottlenecks usually are.
Any specific engine settings?
Yes. The source mentions enabling the Photon engine. It's a cluster setting. Photon is a native vectorized engine that can significantly speed up SQL and Delta operations. Worth checking if it's enabled and suitable for your workload.
Wow, okay. We have really covered a lot of ground here. We've gone from the basics, what Databricks is, the architecture, Unity catalog,
Right, through that whole end-to-end workflow.
to the practical stuff, admin tasks, notebook best practices, data validation, joins.
And finally, those crucial optimization techniques, all pulled from that best practices source document.
Yeah, really trying to distill the actionable advice.
And hopefully, for you listening, the value is clear. You've got a more structured view now. Key terms, commands, and importantly, the why behind these practices.
It's like getting a shortcut based on what actually works effectively in the real world, according to this source.
Exactly. A way to cut down that learning curve.
Absolutely. So as we wrap up, thinking about everything we've discussed today, from the control plane versus data storage distinction, the power of Unity catalog, notebook tricks, data checks, or optimization like Z-ordering or broadcast joins, what's maybe the one thing from this deep dive that really jumps out at you, the listener? What's one practice you think you could implement, or maybe just understand a bit better, that could really make a difference in how you work with data on Databricks?
It's a good question to ponder.
Definitely something to think about as you digest all this information. Which single piece could give you the biggest lift?